All right. Hi, guys. Today, I'm going to be solving a question from the recently conducted IOQM exam this year. So, during my JEE days, this used to be the most fun math exam I'd ever given. And that's why it feels nice to go back and solve a question from this year's version. So, here I am, going to attempt question number 10 from set M1 of the recently conducted exam. So y'all can check the solution and let me know if it's right in the comments. So the data given is the height and base of a closed right circular cylinder. So right circular cylinder is basically going to be something like this. This is the height and this is the base radius. Now H, R both are given to be integers and the total surface area is numerically equal to its volume. So PSA is equal to volume. Now, what's the total surface area of a cylinder? It's going to be the area of the ऊपर वाले cross sections and the नीचे वाले cross section and the curved surface area. So TSA is just going to be the curved surface area, which is going to be 2 pi r into h, because that's circumference into height, as the length and breadth of the rectangle which has been folded into the curved region. And the area of the cross sections at the top and the bottom are going to be pi r square each, so that's just 2 pi r square added. And this is equal to total volume, which is area of base pi r square into height h. So when we do some calculations on both the side, what you get is pi, they get cancelled, and r gets cancelled as well. So you get 2h plus 2r is equal to hr. Right, this is one equation, and the volume is assumed to be k pi. Here we need to minimize k, so least possible volume is what we need to solve for. So the first thing that comes to my mind is get what is volume, right? Volume is just pi r square h. So since we have a relation between h and r, what I'm thinking is we plug in h in terms of r over here so that we get volume as a function of r, and then we take derivative to see how the slope behaves and how the function behaves, the places where it's increasing and decreasing, and then we just find the r at which the function is the relative minimum compared to other integral r. So let's just solve the question through that method. So I'm going to isolate h in terms of r over here. So 2r is going to be h times r minus 2, and h is us 2r by r minus 2. And I plug that in, volume as a function of r is pi r square into 2r by r minus 2. That's 2 pi into r cube by r minus 2. Now I just want to have a look at how this behaves, right? Because 2 pi is a constant, so it doesn't matter. Uh, we just need to see how r behaves. This g of x behaves, g of r behaves as r varies, right? So I'm going to take a derivative of this and see how the slope behaves. So I'm just going to call it slope or something. And is equal to derivative, which is 3r square by r minus 2 minus r cube by r minus 2 whole square using chain rule of derivative. Using the chain rule. Now, when you take LCM, you get 3r square r minus 2 minus r cube divided by r minus 2 whole square. This is going to give you 3r cube minus 6r square minus r cube by r minus 2 cube, which is nothing but 2r cube minus 6r square divided by r minus 2 cube. And you take 2r square common away, you get r minus 3 divided by r minus 2 cube. So what this tells you is the slope of g of x and g of r and thus of v of r, because they just differ by constant, is going to be negative when r is less than 3, and it's going to be positive when r is greater than 3. So the volume function is going to be something like this around r equal to 3. But we cannot just plug in r equal to 3 and find the volume and say that that's the minimum possible volume, because there are two conditions given in the question. R is an integer, which in this case 3 is an integer, and h is also an integer. So we need to ensure first that for r equal to 3, h is also an integer. Because if it's not, then we need to check for r equal to 4 and r equal to 2 and compare which one of them is the lower value and take it to be the lower volume, provided both of them give integral h. So let's just check if h is integral when r is equal to 3. So h at r equal to 3 is going to be 2 into 3 divided by 3 minus 2, which is 6. So h is integral, r is integral. So r equal to 3 पर वॉल्यूम का मिनिमा होगा is minimum at r equal to 3. So that's going to be 2 pi into r cube, which is 3 cube, divided by r minus 2, which is 3 minus 2. That's 27 into 2 pi, which is 54 pi. So the value of k is going to be 54, and thus that is your answer.